ಶುರು ಮಾಡಿದ್ರೆ ಸರ್.
ಬಂದಿದ್ದಾರಾ?
ಜಾಯ್ನ್ ಆಗ್ತಾ ಇದಾರೆ ಸರ್, ಜಾಯ್ನ್ ಆಗ್ತಾ ಇದಾರೆ.
ಆಗ್ಲಿ, ಪರವಾಗಿಲ್ಲ, ಒಂದು 5 ನಿಮಿಷ ಹೆಚ್ಚು ಕಡಿಮೆ.
ಇಲ್ಲ, ಆಗ್ತಾ ಇದಾರೆ ಸರ್, ರನ್ ಆಗ್ಬಿಡ್ತಾರೆ ಹಂಗೇನೆ.
ಸರಿ.
ಯಾಕೆಂದ್ರೆ ನಿಮ್ಮದು ಮುಗಿದ ತಕ್ಷಣ ಮತ್ತೊಂದು 4 ಗಂಟೆಗೆ ಒಂದು ಕಾರ್ಯಕ್ರಮ ಇದೆ.
ಓಕೆ, ಸರಿ.
ಸೊ ಎಲ್ಲರಿಗೂ ನಮಸ್ಕಾರಗಳು. ಇಂದಿನ ವಿಜ್ಞಾನ ಪ್ರತಿಭಾ ಶೋಧನಾ ಯೋಜನೆಯ ಉಪನ್ಯಾಸ ಕಾರ್ಯಕ್ರಮದಲ್ಲಿ ಡಾಕ್ಟರ್ ಶಿಶುಪಾಲ್ ಸರ್ ಅವರು ಉಪನ್ಯಾಸ ನೀಡಲಿದ್ದು, ಸೊ ಈ ಒಂದು ಉಪನ್ಯಾಸ ಕಾರ್ಯಕ್ರಮಕ್ಕೆ ಡಾಕ್ಟರ್ ಶಿಶುಪಾಲ್ ಸರ್ವ ಅವರನ್ನು ಸ್ವಾಗತಿಸುತ್ತಿದ್ದೇವೆ. ವೆಲ್ಕಮ್ ಟು ಯು ಸರ್.
ಥ್ಯಾಂಕ್ ಯು, ಧನ್ಯವಾದಗಳು.
ಸೊ ಅದೇ ರೀತಿ ನಮ್ಮ ಅಕಾಡೆಮಿಯ ಮುಖ್ಯ ಕಾರ್ಯನಿರ್ವಹಣಾಧಿಕಾರಿಗಳಾದಂತಹ ಡಾಕ್ಟರ್ ರಮೇಶ್ ಸರ್ ಅವರನ್ನು ಕೂಡ ಸ್ವಾಗತಿಸುತ್ತಾ, ಅಕಾಡೆಮಿ ಅಧ್ಯಕ್ಷರಾದಂತಹ ಪ್ರೊಫೆಸರ್ ಅಯ್ಯಪ್ಪನ್ ಸರ್ ಅವರನ್ನು ಕೂಡ ಸ್ವಾಗತಿಸುತ್ತಾ, ಸೊ ಇಂದು ಹಾಜರಾಗಿರುವ ನನ್ನ ಎಲ್ಲಾ ವಿದ್ಯಾರ್ಥಿ ಮಿತ್ರರು, ಸಹೋದ್ಯೋಗಿಗಳು ಹಾಗೂ ವಿವೆಕ್ಸ್ ವೃಂದದವರನ್ನು ಕೂಡ ಈ ಒಂದು ಉಪನ್ಯಾಸ ಕಾರ್ಯಕ್ರಮಕ್ಕೆ ಸ್ವಾಗತಿಸುತ್ತಾ, ಸಮಯಾವಕಾಶ ಕಡಿಮೆ ಇರೋ ಕಾರಣ ಸೊ ಈಗಾಗಲೇ ನಮ್ಮ ಡಾಕ್ಟರ್ ಶಿಶುಪಾಲ್ ಸರ್ ಅವರು ನಮ್ಮ ಅಕಾಡೆಮಿ ವತಿಯಿಂದ ಹಲವಾರು ಕಾರ್ಯಕ್ರಮಗಳಲ್ಲಿ ಉಪನ್ಯಾಸಗಳನ್ನು ನೀಡಿದ್ದು, ಹಾಗೂ ಈ ಒಂದು ವಿಜ್ಞಾನ ಪ್ರತಿಭಾ ಶೋಧನೆ ಯೋಜನೆಯಲ್ಲೂ ಕೂಡ ಹಲವಾರು ಉಪನ್ಯಾಸಗಳನ್ನು ನೀಡಿದ್ದು, ಈಗಾಗಲೇ ಅವರ ಬಗ್ಗೆ ಒಂದು ಕಿರುಪರಿಚಯವನ್ನು ಮಾಡಿಕೊಟ್ಟಿದ್ದೇವೆ. ಸೊ ಅವರನ್ನು ನೇರವಾಗಿ ಈ ಒಂದು ಉಪನ್ಯಾಸ ಕಾರ್ಯಕ್ರಮಕ್ಕೆ ಕರ್ಕೋತಾ ಇದ್ದೀವಿ. ವೆಲ್ಕಮ್ ಟು ಯು ಸರ್.
ಥ್ಯಾಂಕ್ ಯು ವೆರಿ ಮಚ್.
ಓಕೆ, ಒನ್ಸ್ ಅಗೇನ್ ಓವರ್ ಟು ಯು ಸರ್.
ಥ್ಯಾಂಕ್ ಯು. ಎಲ್ರಿಗೂ ನಮಸ್ಕಾರ. ಕರ್ನಾಟಕ ವಿಜ್ಞಾನ ಅಕಾಡೆಮಿಗೆ ನನಗೆ ಈ ಅವಕಾಶ ಕೊಟ್ಟಿದ್ದಕ್ಕಾಗಿ ಧನ್ಯವಾದಗಳನ್ನು ಅರ್ಪಿಸ್ತೇನೆ. ಇವತ್ತಿನ ವಿಷಯ ರೋಗಗಳು, ಸಾಂಕ್ರಾಮಿಕ ರೋಗಗಳು ಮತ್ತು ದೇಹದ ಪ್ರತಿರೋಧಕ ಶಕ್ತಿ, ಅಂದರೆ ಮೈಕ್ರೋಬಿಯಲ್ ಡಿಸೀಸಸ್ ಆ್ಯಂಡ್ ಇಮ್ಯುನಿಟಿ ಅನ್ನೋದನ್ನು ಆಯ್ಕೆ ಮಾಡಿಕೊಂಡಿದ್ದೇನೆ. ನಾನು ಸೂಕ್ಷ್ಮಜೀವಿಶಾಸ್ತ್ರಜ್ಞನಾಗಿ ಈ ವಿಷಯದ ಮೇಲೆ ಸ್ವಲ್ಪ ಓದ್ಕೊಂಡು ಸಂಶೋಧನೆ ಮಾಡಿರೋದ್ರಿಂದ ಈ ವಿಷಯವನ್ನು ಆಯ್ಕೆ ಮಾಡಿಕೊಂಡಿದ್ದೇನೆ. ಈಗ ಸೂಕ್ಷ್ಮಜೀವಿಗಳು ಅಂದರೆ ಕಣ್ಣಿಗೆ ಕಾಣಿಸದಿರತಕ್ಕಂತಹ ಜೀವಿಗಳು. ಇವುಗಳು ಎಲ್ಲ ಕಡೆ ಇರುತ್ತೆ. ಈಗಾಗಲೇ ನಿಮಗ ಕೋವಿಡ್ ಸಿಚುವೇಶನಿಂದ ಈ ಆನ್ಲೈನ್ ಕಾರ್ಯಕ್ರಮ ಅಥವಾ ವೆಬಿನಾರ್, ಹಲವಾರು ಜನರು ಸತ್ತೋದ್ರು, ಲಾಕ್ಡೌನ್, ಸೀಲ್ ಡೌನ್ ಆಗಿರೋದ್ರಿಂದ ಒಂದು ಸಣ್ಣ ವೈರಸ್ ಕಣದಿಂದ ಎಷ್ಟೆಲ್ಲ ಸಮಸ್ಯೆಗಳಾಗ್ಬೋದು ಅನ್ನೋದೆಲ್ಲ ನೀವೆಲ್ಲ ಮನಗಂಡಿದ್ದೀರಿ. ಆ ವಿಷಯದ ಮೇಲೆ ಇವತ್ತು ಸ್ವಲ್ಪ ವಿವರವಾಗಿ ತಿಳಿದುಕೊಳ್ಳೋಣ ಅಂತ ಈ ವಿಷಯವನ್ನು ಆಯ್ಕೆ ಮಾಡಿಕೊಂಡಿದ್ದೇನೆ. ನಾನು ನನ್ನ ಸ್ಲೈಡ್ಸ್ ಮೂಲಕ ಇದನ್ನು ಹೇಳಲಿಕ್ಕೆ ಇಷ್ಟಪಡ್ತೇನೆ. ಸೊ ಮೊದಲಿಗೆ ತಮಗೆಲ್ಲ ಈ ಉಪನ್ಯಾಸಕ್ಕೆ ಈ ಸುಂದರವಾದ ಹೂವಿನ ಮೂಲಕ ಆಹ್ವಾನಿಸುತ್ತಿದ್ದೇನೆ, ಸ್ವಾಗತವನ್ನು ಬಯಸ್ತೇನೆ. ಈಗಾಗಲೇ ಹೇಳಿದಾಗೆ ಮೈಕ್ರೋಬಿಯಲ್ ಡಿಸೀಸಸ್, ಸೂಕ್ಷ್ಮ ಜೀವಿಗಳಿಂದ ಉಂಟಾಗುವ ರೋಗಗಳು ಮತ್ತು ಮಾನವನ ದೇಹದ ಪ್ರತಿರೋಧಕ ಶಕ್ತಿ ಅಥವಾ ಇಮ್ಯುನಿಟಿ ಅನ್ನೋ ವಿಷಯದ ಮೇಲೆ ಮಾತಾಡಲಿಕ್ಕೆ ಇಷ್ಟಪಡ್ತೇನೆ. ನೀವು ಜನರಲಿ ಆಲ್ ಆಫ್ ಯು ವಿಲ್ ಥಿಂಕ್ ಆಫ್ ಎ ಹ್ಯಾಪಿ ಲೈಫ್, ಎ ಪರ್ಫೆಕ್ಟ್ ವರ್ಲ್ಡ್ ಯು ಕ್ಯಾನ್ ಡ್ರೀಮ್ ಆಫ್. Good husband, good wife, good children, good school or good principal, good teachers, a lot of money to spend and play around, dance around. That is the perfect world you dream of. But in reality it is not so. ನಾವು ಸಂತೋಷವಾಗಿರಬೇಕು ಅಂದರೆ ಸಾಕಷ್ಟು ಹಣ ಇರಬೇಕು, ಒಳ್ಳೆ ತಂದೆ ತಾಯಿಗಳು ಅಥವಾ ಸ್ನೇಹಿತರು ಎಲ್ಲ ಇರಬೇಕು, ಸಂತೋಷವಾಗಿ ಇರಬೇಕು ಅನ್ನೋದ ಕನಸು ಕಾಣ್ತೀವಿ. But in the real world it is different. As soon as you get up in the morning, one nose is blocked, or there is a stomach pain, or there is a loose motion, or there is a headache. So such problems are referred as diseases or disorders. When I say disease, what is disease? Dis-ease. You are not in ease. You are not normal. There is some problem, right? So what is that problem? And some of the problems associated with our health is due to microorganisms, and such microorganisms which cause disease in other organisms like human beings are referred as pathogens. Pathos, diseased condition, gen, responsible for. Pathogen. ನೀವು ಸೆಕೆಂಡ್ PUC ಚಾಪ್ಟರ್ 8 ಅಲ್ಲಿ ಈ ಅಂಶಗಳು ಇದೆ, ಆದರೆ ನಾನು ಅದನ್ನು ಸ್ವಲ್ಪ ವಿವರವಾಗಿ ಹೇಳಲಿಕ್ಕೆ ಇಷ್ಟಪಡ್ತೀನಿ. Pathogens, disease causing organisms. In a layman term, it is called germs. Germs. These organisms are responsible for some of the diseases in us. So microorganisms, as I mentioned earlier, they are invisible invaders. Without your knowledge, they will be entering you. At the same time, they are amazing allies. They are friends to you. So in high school, you must have studied microorganisms as friends and foes. Why friends? Most of the things, even including our health, is due to microorganisms. Many complex nutrients are digested by microorganisms present in our intestine, and they are responsible for our health, proper health. At the same time, few of them, only few of them, 99.9% of them are good, are not harmful to us. Few of them are harmful. Such harmful pathogens are disease causing organisms, and such disease causing organisms are referred as pathogens. So let us see today some diseases caused by microorganisms and how our body is evolved to prevent such infections. When we talk about human microbiome refers to the total number of organisms, microorganisms present in our body. Total number of bacteria, fungi, virus, all present in our body will be considered under human microbiome. Mother's womb is the best place where there are no microorganisms. As soon as the child travels in the genital tract, child is showered with microorganisms. First ounce of air which enters into the nostril of the child will be carrying the microorganisms. First drop of water the child drinks will be carrying the microorganisms. First piece of food the child eats will be carrying the microorganisms. The relatives, the ayah or nurse or doctor, whoever lifts you up, touches you, will be blessing you with microorganisms. How long? Starting from your birth up to death, you have microorganisms always associated with you, whether inhaling air, drinking food, water, eating food, wherever, everywhere, microorganisms are there. Microorganisms na ubiquitous in occurrence ಅಂತ ಕರಿತೀವಿ. ಅಂದ್ರೆ ಸರ್ವಾಂತರ್ಯಾಮಿ, ಎಲ್ಲ ಕಡೆ ಇದೆ ಅಂತ. ಎಲ್ಲ ಕಡೆ ಇದೆ, ಗಾಳಿ, ಮಣ್ಣು, ನೀರು, ಎಲ್ಲ ಕಡೆ ಇದೆ. ಸೊ ಎಲ್ಲ ಕಡೆ ಇದ್ಮೇಲೆ ನಮ್ಮಲ್ಲೂ ಇದೆ, ಬೇರೆ ಕಡೆನೂ ಇದೆ. ಯಾರ ದೇವರು ಅಂತ ಕನ್ಸಿಡರ್ ಮಾಡಬೇಕಂದ್ರೆ ಸೂಕ್ಷ್ಮ ಜೀವಿಗಳನ್ನೇ ಅಂತ ಅನ್ಬೋದು. ಯಾಕೆಂದ್ರೆ ದೇವರಿನ ಎಲ್ಲ ಗುಣಗಳು ಸೂಕ್ಷ್ಮ ಜೀವಿಗಳಲ್ಲಿದೆ. God cannot be seen, microorganisms cannot be seen. God exists in different forms, microorganisms exist in different forms. God is the one who decides how you have to live, when you have to die. Microorganisms are the one who decides how you have to live, when you have to die. Having said that, you have number of organisms, thousands of organisms on your body, inside and outside. For example, upper respiratory tract, from nose to lungs, as you can see here, 600 plus species of different organisms are there. On your skin, 1000 species are there. In the urinogenital tract, 60 species have been found. Then in the intestine, gut microorganisms, 500 to 1000 species. Then in the stomach, where acid is there, some 25 species of microorganisms are there. That means we have so many organisms always living with us, but we are not suffering every day from diseases. So most of the organisms which we harbor are non-pathogenic, not harmful, and in other words, they are beneficial to us. Only few organisms which are capable of causing disease in us are considered as pathogens. So when we talk about pathogens, disease, whether it is a disease, infectious disease or non-infectious disease, ಸಾಂಕ್ರಾಮಿಕ ರೋಗ, ಅಸಾಂಕ್ರಾಮಿಕ ರೋಗ, ಒಬ್ಬರಿಂದ ಒಬ್ಬರಿಗೆ ಹರಡಿದ್ರೆ ಅದು ಸಾಂಕ್ರಾಮಿಕ ರೋಗ, ಇನ್ಫೆಕ್ಷಿಯಸ್ ಡಿಸೀಸ್. There are some physiological disorders. For example, diabetes. Diabetes ಅಲ್ಲಿ ಇನ್ಸುಲಿನ್ ಕಡಿಮೆ ಆಗುತ್ತೆ, ಹಾಗಾಗಿ a person suffers from diabetes. ಇನ್ಸುಲಿನ್ ರಿಕ್ವೈರ್ಡ್ ಪ್ರಮಾಣದಲ್ಲಿ ಪ್ರೊಡ್ಯೂಸ್ ಆಗಲ್ಲ. ಬಟ್ ಇಟ್ ಇಸ್ ಎ ಫಿಸಿಯಾಲಜಿಕಲ್ ಡಿಸಾರ್ಡರ್. ಅನಿಮಿಯಾ, ರಕ್ತದಲ್ಲಿ ಹಿಮೋಗ್ಲೋಬಿನ್ ಕಡಿಮೆ ಇರುತ್ತೆ ಅಥವಾ ಐರನ್ ಅಂಶ ಕಡಿಮೆ ಇರುತ್ತೆ, ಹಾಗಾಗಿ ಪರ್ಸನ್ ಸಫರ್ಸ್ ಫ್ರಮ್ ಅನಿಮಿಯಾ. It is not infectious. It is not transferred from one person to another person. When we talk about disease, whether the abnormality, disease, uncomfortness or problem associated, whether it is due to an organism, if it is an organism, then that organism is considered as pathogens. Or other physiological disorder, ಅಜೀರ್ಣ ಆಗೋದು, ಹೊಟ್ಟೆ ನೋವು, ಬೇರೆ ಸೂಕ್ಷ್ಮ ಜೀವಿಗಳಿಂದ ಅಲ್ದಲೇ ಬರೋದು, ಅಂಥದನ್ನೆಲ್ಲ physiological disorders. So if it is caused by infection, a pathogen, then such diseases are referred as infectious diseases. Among the infectious diseases, you have viruses, for example, coronavirus, HIV, the AIDS causing virus, hepatitis virus, polio virus, rabies virus. So many different types of viruses are there, which cause problems for human beings and other animals and plants also. And there are other group of infectious agents called viroids, which are small RNA molecules not capable of not having a protein coat, virus having a protein coat and a nucleic acid, whereas viroids are having only RNA capable of causing disease in plants. Then prion is another infectious agent, which is a protein, our own protein becomes abnormal and responsible for bovine spongiform encephalopathy, brain tissue gets degraded. So these three, viruses, viroids and prions, are infectious agents, not organisms. When we talk about organisms, for example, bacteria. Bacteria are single-celled organisms capable of, few of them capable of causing disease. Fungi, then protozoa, fungi, ಶಿಲೀಂಧ್ರಗಳು. Some of them do cause infections like Candida or Aspergillus. Then protozoa, Plasmodium, amoeba, amoebic dysentery, you must have heard. Amoeba, Plasmodium, malaria causing organism, all that comes under protozoa. Then you have nematodes, animal infecting nematodes, plant infecting nematodes. So filariasis and others. Then you have helminthes group, roundworm, hookworm, all that causing infections. So these are infectious diseases ಅಥವಾ ಸಾಂಕ್ರಾಮಿಕ ರೋಗಗಳು. They get spread from one person to another person. For example, during corona, you have seen you are not supposed to come in contact with the corona infected person. So isolation, ಅವರನ್ನ ಬೇರೆ ರೂಮಲ್ಲಿ ಇಡೋದು, ಅವ್ರ ಹತ್ರಕ್ಕೆ ಹೋಗದೆ ಇರೋದು, ಅವರಿಗೆ ಬೇರೆ ಬಟ್ಟೆಗಳನ್ನು ಕೊಡೋದು, ಬೇರೆ ಊಟ ಕೊಡೋದು ಎಲ್ಲ ಮಾಡ್ತಾ ಇದ್ರು. ಅವರನ್ನ ಡಾಕ್ಟರ್ ಟ್ರೀಟ್ಮೆಂಟ್ ಮಾಡಬೇಕಂದ್ರೆ ಫುಲ್ PPE ಕಿಟ್ ಹಾಕೊಂಡು ಕವರ್ ಮಾಡಿಕೊಂಡು ಹೋಗ್ಬೇಕಿತ್ತು. So directly contacting ಬರಬಾರ್ದು. Such pathogens which spreads from one to another and they cause the disease, such diseases are referred as infectious diseases. Whereas non-infectious disease, nutritional deficiency, anemia, diabetes, asthma, they are all non-infectious. They don't spread from one individual to another individual. So why emerging infections? Why corona appeared? World population growth. More and more human beings are growing, being born. So you have more and more contact with each other. And unlike earlier days, ಒಂದು ಹಳ್ಳಿಯಲ್ಲಿ ಒಂದು ಮನೆ ಇದ್ರೆ ಅಲ್ಲಿ 4 ಜನ ಇರ್ತಿದ್ರು, ಅವ್ರಿಗೂ ಇನ್ನೊಂದು ಜನಕ್ಕೂ ಸಂಪರ್ಕ ಬರ್ತಿರ್ಲಿಲ್ಲ. Whereas now you have increased population, there is a contact between individuals more. If I am infected and if I go and meet others, there is a likely chance that the pathogens from me goes to them. Then urbanization resulting in all sorts of filth around, ecological disturbances, technological advances, microorganisms are evolving every day and they are adapting to us. Human behavior, for example, ರಸ್ತೆಯಲ್ಲಿ ಹೋಗ್ತಾ ಇದ್ರೆ ತುಪ್ಪ ಅಂತ ಉಗಿಯೋದು, ಸಿಂಬಳ ಸೀನ್ ಹಾಕೋದು, ಅಲ್ಲಿ ಸಿಂಬಳ ಹಚ್ಚೋದು, attitude, all this helps in spread of the disease. So emerging infections because of many human-centric activities. The presence of microorganisms was first felt by Anton van Leeuwenhoek. Though microorganisms were there earlier, Anton van Leeuwenhoek made observations through his microscope, a small microscope, and then said small microscopic organisms are present. Now we know if we have a nutrient medium, this is a plate, Petri plate it is called, containing nutrient medium exposed to air. You can see many bacterial colonies there, fungi growing. That means air contains so many organisms. So I will touch upon different groups of infectious agents and later touch upon certain diseases. For example, this is a virus structure, rabies virus. The shape of the virus is bullet shaped, but it can be seen only in electron microscope. Then HIV looks like this. HIV is one of the virus, human immunodeficiency virus, and you have a lesson on this. So HIV is one such virus. The corona is this virus, it is called SARS-CoV-2. This virus is an RNA virus. The HIV is an RNA virus. Like that, there are viruses containing RNA or DNA, double-stranded RNA, single-stranded RNA, double-stranded DNA or single-stranded DNA containing viruses are there, covered with a protein coat. That's why virus particle is referred as nucleoprotein, nucleic acid plus protein. Then these are only few examples for viruses. Like that, tuberculosis, it is a bacterial disease. Mycobacterium tuberculosis, when it is grown on the medium, it looks like this. There are bacteria, for example, Escherichia coli, present in your intestine, looks like this, the rod-shaped bacterium. Neisseria gonorrhea, gonorrhea causing bacteria. Bacteria are single-celled prokaryotic organisms. The cocci or round-shaped cells can be seen in this picture. Then Staphylococcus looks like a bunch of grape. This is one of the bacterial genera. Then I have given 3 examples for virus, 3 examples for bacteria, and few examples for fungi. For example, bread mold. If you keep a bread in a moist condition, you will get the growth of the fungi from air. They come and land onto the bread and they start growing there. Groundnut. Groundnut being shown to have many fungi. The fungi, kadle bija tinta iruvaga onondsala kahi taste barutte. It is because of these fungi like aspergillus. Then protozoa, you have amoeba, paramecium, plasmodium and things like that. Nematodes, they will be looking under microscope like this. Then these microorganisms are very small. They are inferior in their individual energy. When you compare to a lion or elephant, they are kitanu, tuchcha jeevigalu, right? But in their united influence, they are far more important than these animals. They can kill a lion, an infection can kill an elephant or a blue whale or human beings. So, though very small, very minute, not to be seen by naked eye, they are capable of killing an animal or causing problems to bigger animals or plants. Some common examples of the diseases. This is gingivitis. ಹಲ್ಲು ನೋವು, ಹಲ್ಲು ಕುಳಿ ಬರುತ್ತೆ, ಅಲ್ಲೆಲ್ಲ ಹುಳ ಹಿಡಿದಿದೆ ಅಂತಾರೆ. ಹುಳ ಹಿಡಿದಿರೋದು ಅಂದರೆ there are bacteria which are degrading the teeth. How common this gingivitis is? In America, this is information is from Guinness Book of World Record. The most commonest disease is the gingivitis. 80% of the US population suffer from this disease. What does it mean? You have best clean environment there, toothbrush, best paste, best everything, but still 80% of the United States people suffer from gingivitis. The next sentence is difficult to believe. In Great Britain, 13% of the people have lost their teeth before reaching 21 years. 21 ವರ್ಷ ಆಗೋದ್ರೊಳಗೆ ಹಲ್ಲೆಲ್ಲ ಬಿದ್ದೋಗ್ಬಿಡುತ್ತೆ. It is very strange, but you need to believe because it is from Guinness Book of World Records. But you must have seen your grandparents or great-grandparents having still all the teeth intact. During their lifetime, few completely escape its effects. The other problem, the common problem which you notice is the common cold, Shita. So what is the symptom of common cold? The running nose, simla surita irutte muginda. Then she has found a better method of tackling common cold. So she has got a running tissue to clean it. Then the other symptom is sneezing. When you sneeze, the nasal secretion carrying the virus particle goes as a droplet nuclei. In front, whatever you are seeing small droplets, they are referred as droplet nuclei carrying the virus. If an infected person sneezes, he pushes the virus along with his nasal secretion into the environment, and the other people present there will be carrying the virus. How severe common cold is? In one day, 137,000 Americans stay at home because of common cold. 164,000 children don't go to school for the same reason. Common cold is caused by a group of viruses called rhinoviruses. They are single-stranded RNA virus. They spread from one person to another person through handshaking. ಹಿಂಗೆ ಸಿಂಬಳ ಒರೆಸ್ಕೊಂಡಿರ್ತಾರೆ, ಅದೇ ಕೈಯಲ್ಲಿ ಇನ್ನೊಬ್ಬರಿಗೆ ಮುಟ್ತಾರೆ. ಅವರು ಮತ್ತೆ ಮೂಗಿಗೆ ಟಚ್ ಮಾಡ್ಕೊಳ್ತಾರೆ, ಅವಾಗ ವೈರಸ್ ಹೋಗುತ್ತೆ. ಅಥವಾ ಯಾರಾದರೂ ಸಿಂಬಳ ತೆಗೆದ್ಬಿಟ್ಟು ಕುರ್ಚಿಗೆ, ಬೆಂಚಿಗೆ, ಸಿನಿಮಾ ಥಿಯೇಟ್ರಲ್ಲಿ ಅಂಟಿಸಿರ್ತಾರೆ, ಅದರಿಂದ ಇನ್ನೊಬ್ಬರಿಗೆ ಹರಡುತ್ತೆ. ಸೊ ಕಾಮನ್ ಕೋಲ್ಡ್ ಈಸ್ ಟ್ರಾನ್ಸ್ಮಿಟೆಡ್ ಥ್ರೂ ಏರ್ ಆರ್ ಪರ್ಸನಲ್ ಕಾಂಟ್ಯಾಕ್ಟ್. The other viral disease is chickenpox. I am sure most of you would have had this problem. Chickenpox is caused by a virus where the symptoms appear on the body as rashes, small rashes appearing all over. By 15 to 20 days, it gets reduced, and the powder, skin powder, carrying the virus particle will be transmitted to other children in the school if they sit next to next. The powder, skin powder, or dried skin powder carrying the chickenpox virus will be going to other individuals, other children, and they suffer from. So after it is considered as a self-limiting disease, as your immunity goes up, the virus gets subsided. But the virus stays in your body for a long time. Only the symptoms go off. But the virus, when you are old, when you have used steroids for allergic reaction, or when your immunity comes down, the same virus expresses as herpes or sarpasuttu, sarpa hunnu. So it appears on the skin, producing the rashes. So chickenpox in children, the same virus causes herpes in adults. There are oral herpes also. These are some of the diseases, mumps. These are all some of the diseases caused by viruses. Coming to bacteria and HIV. HIV is one deadly disease which has increased over a period of time. This is from WHO website. From 1992 to 2008, if you see, there is increase in number of HIV infected individuals. All of them will not die immediately. The number of individuals are more. If you see, the number of deaths due to AIDS is only small, that pink graph. So infection is more, they will be spreading to others. Death rate is not so much like corona or other. The coming to bacterial diseases, some of the bacterial pathogens are there. For example, Clostridium tetani. Clostridium tetani enters our body through wound, causing tetanus. For example, if you meet with an accident athwa gaya giya agidre, when you go to a doctor, he will ask for a TT injection. TT injection refers to tetanus toxoid. It will be given to you. Your immunity will be upgraded to fight against the possible infection through wound. Otherwise, intact skin will be able to protect you against Clostridium tetani. Mycobacterium leprae, ಕ್ಷಯ ರೋಗ ಅಂತ ಕರೀತಾರೆ. Not many now because the effective drugs have come. This is another bacterial disease. Then little more serious diseases. In one day, 2,700 Americans discovered that they have gonorrhea. Gonorrhea is a sexually transmitted bacterial disease. 200 of them, 200 discovered that they have syphilis. Another bacterial disease. Gonorrhea is caused by Neisseria gonorrhoeae, the bacterium. Syphilis is caused by Treponema pallida. Gonorrhea from the infected mother, it can get transferred to the child during birth, and child may get infection. This is syphilis at tertiary level, higher level. Then the food what we eat is contaminated. Either animals like rat here, for example, it has become a sandwich. The animal has come, the feces or body organisms present in the animals would have got carried. For example, you must have heard or studied coronavirus in Wuhan, the place China where wildlife market is there, where they had used pangolin or bat, and the virus got transferred from bat possibly to human beings and caused the problems. You have bacteria like Salmonella typhi present in food, causes typhoid, salmonellosis, and other diseases. So if undercooked or uncooked meat is consumed, if it is contaminated with a bacterium like Salmonella, it can result in foodborne infection. Whether you are vegetarian or non-vegetarian, Salmonella poisoning is possible. If it is contaminated and if it is not cooked properly, not treated properly, it will result in typhoid or salmonellosis. Then coming to fungi. Fungi, there are only few fungi which can cause disease in human beings. For example, this is oral candidiasis. Candida, one of the yeast forms growing in the mouth of the patient. Then aspergillosis, causing superficial skin infections on the skin. Then in corona cases, you must have heard mucormycosis. These are all some of the patients showing mucormycosis. The mucormycosis disease was there earlier, caused by fungi, mucor, rhizomucor, and others. But during corona, their incidence got increased. So it is important for us to know some of these microbial diseases. Then if you coming to protozoa, malaria is one such example. Malaria is caused by Plasmodium. There are 4 species of Plasmodium. Plasmodium falciparum, Plasmodium vivax, Plasmodium malariae, and Plasmodium ovale. These 4 species are responsible for malaria. 4 people in USA discover that they have malaria every day. Each year, 150 million people become infected by Plasmodium and 3 million die due to malaria. It is one of the serious diseases, and in your book there is a reference for this. So you have viral diseases, bacterial diseases, fungal diseases, and protozoal diseases. Malaria pathogen is present in your blood. See, this is the blood where malarial pathogen can be seen, Plasmodium can be seen. When Anopheles mosquito, the female mosquito, feeds on the infected individual, carries the blood, along with the blood, the malarial pathogen gets entry into the insect body, the mosquito. The same mosquito infecting, sucking blood from the other will be able to transfer Plasmodium from infected individuals to healthy individual. That means, for example, common cold can get transferred from one to another by air, transmitted through air. But some of the pathogens like malarial pathogen Plasmodium can get transferred from one to another through a vector. Vector is Anopheles mosquito. Dengue virus is transmitted through mosquito. Like that, you have other organisms. Cassonorofares disease virus transferred through ticks. So other insects which are biting human beings can carry the pathogens from one to another. This reference is also there, Anekalu roga, elephantiasis, or it's also referred as filariasis. Wucheria bankrupti is the small nematode worm which causes filariasis or the elephantiasis. So there are few diseases caused by viruses, bacteria, fungi, and then parasites, roundworm, hookworm, and others. But for all these disease treatment, you go to a hospital where you may get infection because at home you are free from most of the pathogens are not there. But in a hospital environment, many people are there and they are carrying the infectious agent and they can supply to you. So if you are gone to an hospital or a clinic, you are expected to get many infections. These are technically referred as hospital acquired or nosocomial infections. There is an interesting information. In one day, 7,000 hospital patients become infected with an illness other than the one that sent them to hospital. You may drink contaminated water, contaminated food, and you may get infected by other organisms. Such infections are referred as nosocomial infections. Oh, ಏನಪ್ಪ disease ಹೆಸರೆಲ್ಲ ಹೇಳ್ಬಿಟ್ರು, ಇಷ್ಟೊಂದು disease ಎಲ್ಲ ತೋರಿಸ್ಬಿಟ್ರು, ಹೆದರಿಕೆ ಆಗಿದೆಯಾ ಅಂತ. No, most part of our life we are happy, healthy. It is because we have well developed immune system. This is nosocomial infection. Plants also get infection. For example, this is tobacco plant having tobacco mosaic virus. This is potato infected with Erwinia keratophora, the bacterium. So both ಏನೋ ಒಂದು ಗಾದೆ ಇದೆ, ಕಷ್ಟ ಮನುಷ್ಯನಿಗೆ ಬರದಿಲ್ಲ ಮರಕ್ಕೆ ಬರುತ್ತೆ ಅಂತ. ಮರಕ್ಕೂ ಬರುತ್ತೆ, ಗಿಡಕ್ಕೂ ಬರುತ್ತೆ, ನಮಗೂ ಬರುತ್ತೆ. We have to fight against. So what I have shown so far, that my few organisms considered as pathogens are capable of causing disease in human beings, animals and plants. With respect to human beings, we have a well-developed immune system. The defense mechanism, what we have, immunis refers to free from infection. The system which helps you free from infection is immune system. You have digestive system, circulatory system, like that immune system which help protects you against infectious agents. When we talk about immune system, what are the important characters of immune system? It is extremely defensive system, adaptive defense system. The system which is fighting against virus, fighting against bacteria, fighting against fungi will be different. It is extremely adaptive. Then it has evolved in vertebrate animals to protect against invading microorganisms and also against cancer. It is highly complicated network of different organs and cells which mutually interact and helps in protection. And the recognition is remarkable for its specificity. Our immune system recognizes coronavirus as a separate enemy, HIV as a separate enemy, Staphylococcus the bacterium as a separate enemy, Vibrio cholera causing bacterium as separate enemy. So specificity is of highest order as far as our immune system is concerned. For example, you have police, home guards, right, and soldiers, navy, army, air force, in order to tackle the enemies coming from different routes. Like that, we do have different cells which are acting like a soldiers, looking for the pathogen and they will be killing. So when we talk about host defense mechanism or immunity, immunis refers to free from infection, immunity, state of protection. So there are two categories. One is non-specific or innate immunity. It is already there, inborn. Like biological barriers, you have skin acting as a physical barrier. I did give the example, Clostridium tetani can enter into the human tissue only through wounds. Intact skin acts as a barrier. ಮೊದಲೆಲ್ಲ ಹಳೆ ಕಾಲದಲ್ಲಿ ಕೋಟೆ ಕಟ್ತಾ ಇದ್ರು, ಕೋಟೆನ ಒಡ್ಕೊಂಡು ಒಳಗೆ ಬರೋದು ಕಷ್ಟ ಆಗ್ತಾ ಇತ್ತು. Like that, there is a physical barrier, chemical barrier. Our body glands produce many compounds. For example, in your sweat glands, fatty acids are there which are liberated and present on your skin. Some of them are antimicrobial in nature. The saliva has got lysozyme which will be digesting the bacteria coming through food. ಏನಾದರೂ ಧೂಳು ಬಿದ್ದ ಕೂಡಲೇ ಕಣ್ಣೀರು ಬರುತ್ತೆ. The tears is having compounds which can kill microorganisms so that prevent infection of the eye. And some of the cells referred as phagocytic cells, they will be surveying in your blood, and whenever there is an entry of an organism, they will do phagocytosis, engulfing, eating by the cell. They engulf and destroy the pathogen. Whether the pathogen comes or not, these are already there. ಕಳ್ಳ ಬರ್ತಾನೋ ಬಿಡ್ತಾನೋ ನಮ್ಮ ಎಚ್ಚರಿಕೆಯಿಂದ ನಾವಿರಬೇಕು. So innate immunity factors are always active in protecting us. But the second part is specific immunity, specific against a target enemy, and it is acquired in your lifetime. For example, polio vaccination, ನಿಮ್ಮ ತಂದೆ ತಾಯಿಗೂ ಮಾಡಿರ್ತಾರೆ, ಆದರೆ ನಿಮಗೂ ಮಾಡಬೇಕು. You have to get it. Though you have got genes coming from the parents, you need to get the vaccination done. There are two methods of getting protection, immunity. One is natural, the other one is artificial. In natural, for example, you get an infection and after a few days you will recover from infection. Your body will become resistant to that particular pathogen. This is natural. Your immunity is activated because of natural infection. So it is referred as natural active immunity. here in the center. You are acquiring immunity because of natural infection. The second is natural passive immunity. You are not doing anything, but you are getting the protection. How? When you are a kid, the mother would have got exposed to many pathogens. She has produced immunoglobulins against specific pathogens. Those immunoglobulins gets transferred through placenta when the child is in the form of a fetus, or then it is transferred through breast milk. ಎದೆ ಹಾಲು ಕುಡಿಸೋದ್ರಿಂದ ಮಕ್ಕಳಿಗೆ ದೇಹದ ಪ್ರತಿರೋಧಕ ಶಕ್ತಿ ಬರುತ್ತೆ ಅಂತ ಕರೀತಾರೆ, ರೈಟ್? ಸೊ ದ ಚೈಲ್ಡ್ ಈಸ್ ನಾಟ್ ಡೂಯಿಂಗ್ ಎನಿಥಿಂಗ್, ಇಟ್ ಈಸ್ ನ್ಯಾಚುರಲಿ ಗೆಟಿಂಗ್ protection from mother. That's why it is called natural passive immunity. Then immunity can also be induced by artificial methods. How is that possible? For example, immunization or vaccination. You are all vaccinated for corona. So your immunity is activated. You have acquired that immunity by artificial method of vaccination, that is artificial active immunity. So you will produce antibodies against the, for example, coronavirus vaccine I have taken. You produce the antibody against coronavirus and hence get the protection. Then in some cases, you will be able to get immunity. For example, snake bite cases. A cobra has bitten, then venom is there in the body of the individual, that has to be neutralized. The person doesn't have resistance against the cobra venom. So antibodies or the immunoglobulins molecules produced against the cobra venom in horse is taken and transferred into the snake bitten individual. So that antibodies produced in horse against the venom is called anti-venom, antibody against the venom, and that is transferred to us so that we get the toxin gets neutralized by the antibody. I am not resistant to venom, but I get protection, and hence it is an artificial method. It is an artificial passive immunity. I hope with suitable examples I was able to distinguish them. But still, I'll repeat in a different way. Natural active, it should be natural. Your immune system should get activated. So infection, natural active. Artificial active immunity, your immune system should get activated by, it is an artificial method of vaccination. The vaccine is given to you in order to get protected. Natural passive, from mother to the child. Artificial passive, like anti-venom produced in, antibodies produced in horse given to the patient bitten by a snake. So, or dog bite against rabies virus. So in such cases, antibodies are given. It is artificial passive immunity. So I did mention earlier, there are different organs of immune system. One such primary lymphoid organ is the bone marrow, asti majje anta karitare, where cells of the blood gets formed. Hematopoietic stem cells gets formed in bone marrow, and they are fighting against the infectious agents. The other primary organ is called thymus, a bilobed structure near the heart. So this is thymus, where some of the cells produced in bone marrow goes to thymus and they get matured into T lymphocytes. So one group of cells produced in bone marrow gets matured in bone marrow, they are considered as B lymphocytes. The other groups of cells produced in bone marrow gets matured in thymus are referred as T cells or T lymphocytes. Then there are other regions, organs like spleen, lymph node, tonsils. All these act as secondary lymphoid organs. It is in case of both male and female, these organs are same. How it occurs? The process of formation of blood cell is called hematopoiesis. In the bone marrow, there are hematopoietic stem cells, precursor for stem cells. They are capable of dividing. Totipotency, ability to divide, is already there. Additionally, the hematopoietic stem cells have got pluripotency. Pluripotency to become anything, different types of cells like RBC or WBC, different types of cells from the same cell is possible. So pluripotent cells. So in the bone marrow, during hematopoiesis, one group of cells becomes lymphoid stem cell and they get converted into B lymphocytes and T lymphocytes. They are extremely important in recognizing the pathogen and kill the pathogen. On the contrary, hematopoietic stem cell becomes erythroblast. Erythroblast later gets developed into erythrocytes or RBC, red blood cells. Then megakaryoblast into megakaryocytes, they become platelets. Then myoblasts, they become eosinophil, basophil and neutrophil. Then monoblast, they get converted into monocytes and later become macrophage. If you look into it, whether it is RBC or all other cells are coming from hematopoietic stem cells. All these cells are WBC, commonly referred as white blood cells, because they don't have hemoglobin, red colored hemoglobin, whereas RBCs are having red colored hemoglobin, red blood cells. These cells, the white blood cells, are responsible for our immunity. So here this picture shows both presence of red blood cells and white blood cells. When a B lymphocyte interacts with the antigen, becomes effector B cell, get converted into plasma cell and produce the antibody molecule. So ability of B lymphocytes to recognize an enemy and produce antibodies or immunoglobulins. Then T cells also recognize the antigen and they produce certain compounds called cytokines, which will be activating the B cell to become plasma cell or producing cytotoxic factors. We have an infected cell, then that gets killed by TC cell, cytotoxic T lymphocytes. So mainly B cell produces antibody, T cell helps antibody production as well as killing of infected cells. If you take a bacterium, the whole bacterium is not recognized by our immune system. Each bacterium may have several antigenic determinants or epitopes of different size, shape, number. For example, this is a bacterial cell having different epitopes on them or antigenic determinants. And they get recognized by immunoglobulins produced by us. When this bacterium or a virus particle enters to our cells, our B lymphocytes recognize it and produce antibody molecules. T lymphocytes kill infected cell. So there are so many processes to protect against infectious agents taking place, interacting the cells, B lymphocyte, T lymphocytes interact and they fight against. So when different organisms like proteins, viruses, bacteria, parasites, fungi enter into a vertebrate body like a mouse or a human being, B cells gets activated and produce the antibody molecule immunoglobulins. T cells gets activated, they help the B cell to produce the antibody. T cells goes and kills infected self cell. So here you see the pathogen has entered, the pathogen is taken up by studied by B cell and you have B cell getting activated to produce the immunoglobulin molecules. At the same time, macrophages destroy the pathogen. Macrophages will be able to activate the T cells and then T cells will go and activate the B cells to produce the antibody. So different cells are interacting with each other to produce the antibody molecules. So among several B cells, whenever, for example, Nimatra Tumba Nurar B cells ide, one recognizing coronavirus, one recognizing HIV, one recognizing hepatitis, one recognizing salmonella, or any organism coming from outside will be recognized by your immune system. And once that enters, for example, common cold agide, cold virus has entered, cold virus recognizing B cell will start multiplying, increase in its number. Terrorist activity agide andre, immediately soldiers will be deputed there. Exactly in the similar way, your body will depute more and more cells to protect against that particular virus. So how protection occurs? I did mention phagocytic cells, macrophages or phagocytic cells. They engulf. Look at this video. When they engulf, see macrophages moving in the blood, and whenever there is a bacterial cells coming into the blood, for example, these green colored cells, bacterial cells, they are tackled, engulfed by the bacterium, and immediately the signal is sent that there is an entry of an enemy, immediately become alert through cytokines. So these cytokines go and activate B cells, T cells, and all other cells that there is an infection. Then you will immediately get the fever. So in how our immune system recognizes, there are several infectious agents. One particular WBC called APC will catch hold of a infectious agent, shows it to the T cells. T cells shows this triggers the B cells. B cells will produce the antibody molecule. These antibody molecules go and kill the pathogens. That's why antibody molecules are considered as magic bullets. So what are these antibodies? They are proteins, our own proteins, produced in response to entry of a foreign molecule or a pathogen. And they are produced by plasma cells, which are a group of B lymphocytes. The antibodies are circulated in the blood and lymph. Whenever there is an entry of a pathogen, they will be able to hold or neutralize it. When we take our blood, the liquid portion of the blood is called plasma. If you allow the blood to clot, you will get the clear supernatant as serum. Serum containing the antibody is antiserum. So this is an immunoglobulin structure, immunoglobulin or antibody molecule. There are two heavy chains, there are two light chains. And there is a region called antigen binding site. There are two such antigen binding sites and a constant region. This is the structure of immunoglobulin given in your book. So it is a globular protein. It is called immunoglobulin because it is produced in response to infection. So the antigen binding site here exactly fits into a particular virus. If the virus is different, for example, this is polio virus, this is rabies virus, this is HIV, all the components are recognized differently. So antibody is highly specific. Recognizing HIV will not recognize rabies. The antibody recognizing rabies will not recognize other corona or other. Now you are all vaccinated for coronavirus. So vaccine is recognized by B lymphocyte and antibodies are produced in your blood, which will be protecting the or neutralizing the coronavirus if it comes. So whenever there is a first entry of the pathogen, immediately the response will be there between 10 to 15 days. Then if the same pathogen enters your body, the response is much faster because more number of B lymphocytes respond against that particular immunogen. So when the antibodies are there, they have different roles to play. I'll just touch upon a virus is entering. The antibody against coronavirus will go and block the virus without allowing it to multiply. That is called viral neutralization. If there is a venom injected to me, snake bite has taken place, then antibodies to venom go and neutralize, toxin neutralization. Then if there is a bacterium, antibody specific to bacterium go and bind to the bacterium and it is phagocytosed by our phagocytic cells. Antibody dependent cytotoxicity, infected cells are killed by our T lymphocytes. So there are so many different roles. These antibody molecules neutralize the virus, neutralize the toxin, identify the pathogen to get killed by phagocytosis. So this immune system provides you protection. So most part of your life, you are healthy because of the beautiful immune system working against. It can fight against cancer, but if there is a problem of immunity is low, results in immunodeficiency, In case of HIV infected individuals, HIV goes and kills the T lymphocytes and hence his response is low. Allergic reaction, you touch Parthenium, some people show allergic reaction. Nasal secretion, sinus, all that is because of the immune system. Then graft acceptance, kidney is donated from one person to another person. Graft acceptance or rejection is because of the immune system. Then there is a allergic reaction. Allergic reaction, some of the people are allergic. For example, some people are allergic to dust. Some people are allergic to pet animals' hairs. Some people are allergic to pollen or fungal spores. So such people need to get a skin allergy test like this. So as you can see here, the cat feather component is injected, dog feather component is injected, horse, sheep, like that. And if there is a swelling near the injection point and reddening, that is called inflammation. Swelling and reddening is called inflammation. It shows that you are allergic to that. And best method to avoid allergy is to avoid getting exposed. Then there are various allergic tests are available. Having understood the diseases and the immune system, wonderful immune system which is protecting against you, is the vaccination. How to use this knowledge to protect us. Best example in the recent days is the COVID situation. 2019 December, COVID started, but 2020 it spread across 200 countries, and all of us have suffered from not going to school, not going to college, not meeting friends, isolation, lockout down, everything. But the solution for such a big problem of the disease worldwide was the vaccine development. Vaccine is what? Vaccine was developed by Edward Jenner for the first time against smallpox virus. He was a doctor in England. He knew from milkmaid, so they used to get a mild infection of cowpox, and cowpox material injected into another healthy person protects him against smallpox. So this is the boy, 1796, who received first time the cowpox material as a vaccine molecule against smallpox virus. Later, Louis Pasteur developed against rabies, and now different diseases, MMR, DPT, diphtheria, pertussis, tetanus. So many vaccines have been designed, developed successfully, and hence infectious diseases have come down. So number of vaccines are available, including corona vaccine. One I just highlight here. Oral polio vaccine is developed by Sabin, Alfred Sabin. India is free from polio because of this great individual's contribution. He used weakened virus as a vaccine molecule put with the sugar drop into the child mouths. The virus enters, it don't have disease causing ability, that means pathogenicity is not there, but it will induce immune response in us. When the real virus comes, it will be taken care by our antibodies. So he has used the experimental animals to develop polio vaccine, and because of him we are standing on our two legs. Look at the vaccine. Because of the Alfred Sabin contribution, people all around the world with hundreds, irrespective of the country, creed, all of us are standing on our two legs because of the polio vaccine successful. Like that, tuberculosis, BCG vaccine, diphtheria, pertussis, tetanus, DPT vaccine, poliomyelitis, oral polio vaccine. Like that, different vaccines are already available, which are made by WHO, World Health Organization, as mandatory in different countries. Then the vaccines are developed by different methods. Earlier, for example, in 1798 against smallpox, using cowpox, chemical attenuation, rabies virus exposed to formaldehyde, or oral polio vaccine developed through monkey and chimpanzee. Then now today you have vaccine against COVID, the virus particle itself, or its gene is introduced to us, For example, you have available COVID vaccine developed by Oxford AstraZeneca is the Covishield. Then the other one developed by Bharat Biotech is the Covaxin. Then the other one is the Sputnik. So Covishield produced in Serum Institute of India, Covaxin produced by Bharat Biotech at Hyderabad. Like that, different companies and government organizations work together, and the science helped in preventing the spread of the COVID, and now coronavirus has been controlled to largest extent. Because of understanding of the immune system, because of understanding of the disease, it was possible to develop effective vaccine against COVID. So other COVID virus vaccines available, Moderna, Pfizer, J&J, Johnson and Johnson. These are the vaccines available throughout the world now fighting against COVID. So using our immunity, knowledge of immunity and knowledge of the disease, it was possible for scientists to develop vaccines, and that is where you are preventing. Prevention is better than cure. You are preventing the disease. So in case if the immunity fails, you need to take antibiotics and other drugs which will be protecting. So effective vaccines, effective antibiotics have protected us against infectious agents, and the beautiful immune system working wonderfully well in identifying each target pathogen and fighting against it. So most of the microorganisms are not pathogenic. I repeat, most of the microorganisms are not pathogenic. Only few which are causing disease are referred as pathogens, and such diseases which can spread from one to another is referred as infectious disease. And we have vertebrate animals have developed an exceptionally wonderful immune system which protects you against infectious agents. And the vaccines are produced after understanding microbial diseases as well as immunity. We have been able to produce vaccines to prevent rabies or hepatitis or including the present corona. So definitely understanding of the immune system helps to fly high and reach our goal. Thank you very much. If there are any questions, if the organizers permit, I will be able to attend. Hello.
Sir.
Okay,
thank you, sir.
Thank you.
So, dear students, please ask any questions or doubts on today's topics. ಯಾವುದೇ ನಿಮಗೆ ಇವತ್ತಿನ ಒಂದು ಉಪನ್ಯಾಸ ಕಾರ್ಯಕ್ರಮದ ಈ ಒಂದು ವಿಷಯದ ಮೇಲೆ ಡೌಟ್ಸ್ ಆಗಲಿ, ಯಾವ್ದಾದ್ರು ಕ್ವಶನ್ಸ್ ಕೇಳೋದಿದ್ರೆ ನಮ್ಮ ಶಿಶುಪಾಲ್ ಸರ್ ಅವರಿಗೆ ನಿಮ್ಮ ಎದುರಿಗೆ ಇರೋದ್ರಿಂದ ತಾವೇನೇ ಒಂದು ಡೌಟ್ಸ್ ಇದ್ರೂ ಕೇಳುವಂತ ಸಮಯ, ತಾವೆಲ್ಲರೂ ಕೇಳಿ ಅಂತ ಚಾಟ್ ಬಾಕ್ಸ್ ಅಲ್ಲಿ ಒಂದ್ಸರಿ ಚೆಕ್ ಮಾಡಿದ್ರಿ ಸರ್. ಸೊ ಚಾಟ್ ಬಾಕ್ಸ್ ಅಲ್ಲಿ ಯಾವ್ದೇ ಕ್ವಶನ್ಸ್ ಇಲ್ಲ. ಸೊ ಅವ್ರೇನಾರ ಕಳ್ಸಿಕೊಟ್ರೆ ನಾನು ಲೇಟರ್ ಆನ್ ಸೆಂಡ್ ಥ್ರೂ ಕಳ್ಸಿಕೊಡ್ತೀನಿ ಸರ್. ತಾವು ಕಳ್ಸಿಕೊಟ್ರೆ ಆ ಪಿಪಿಟಿನೂ ಕೂಡ ಮಕ್ಕಳುಗಳಿಗೆ ನಾನು
ಸರಿ
ನಾನು ಶೇರ್ ಮಾಡ್ತೀನಿ ಸರ್.
ನಾನು ಸಮ್ಮರಿ ಕಳಿಸ್ಕೊಡ್ತೀನಿ.
ಪ್ಲೀಸ್ ಸರ್ ಕಳ್ಸಿಕೊಡಿ ಸರ್, ಕಳ್ಸಿಕೊಡಿ, ಸಮ್ಮರಿನ ಕಳ್ಸಿಕೊಡಿ.
ಓಕೆ
ನಾನು ಸೆಂಡ್ ಮಾಡ್ತೀನಿ ಸರ್.
ಸರಿ.
ಸೊ ಥ್ಯಾಂಕ್ ಯು ವೆರಿ ಮಚ್ ಸರ್. ಇಟ್ಸ್ ಅನ್ ಇಮೆನ್ಸ್ ಪ್ಲೆಜರ್ ಟು thanks to Dr. Sisupal sir. So you are giving a wonderful, very informative talk on immunity and some diseases.
Yes.
So this talks gives many information to all the students. So,
thank you very much for KSTA for providing the opportunity, and I wish you all the best.
Thank you sir. ಸೊ ಇವತ್ತು ತಾವು ಕೊಟ್ಟಂತ ಉಪನ್ಯಾಸ ಕಾರ್ಯಕ್ರಮ ಕನ್ನಡ ಮತ್ತು ಇಂಗ್ಲಿಷ್ ಎರಡರಲ್ಲೂ ಕೂಡ ಮಕ್ಕಳುಗಳಿಗೆ ಯಾವ ರೀತಿ ಒಂದು ರೋಗ ಅಂತಂದ್ರೆ ನೋಡಿ, ನೀವು ಯಾವುದೇ ಒಂದು ದೊಡ್ಡ ರೋಗದ ಬಗ್ಗೆ ಹೇಳ್ಬಿಟ್ಟು ನಿಲ್ಸುವಂತ ಸಂದರ್ಭ ಇತ್ತು. ಬಟ್ ಆದ್ರೂ ಕೂಡ ತಾವು ಒಂದು ಹಲ್ಲು ನೋವಿನಿಂದ ಹಿಡಿದು ಕೋವಿಡ್ ವರ್ಗುನು ಕೂಡ HIV ಬಗ್ಗೆ ಯಾವ ರೀತಿ ಬರುತ್ತೆ, ಅದನ್ನ ಯಾವ ರೀತಿ ಹೋಗಲಾಡಿಸ್ಕೋಬೇಕು ಅನ್ನೋ ಒಂದು ವಿಚಾರಗಳನ್ನ ಭಾರಿ ಸಮಾಲೋಚನೆಯಿಂದ ಭಾರಿ ಇನ್ಫಾರ್ಮೇಟಿವ್ ಆಗಿ ತಿಳಿಸ್ಕೊಟ್ಟಿದ್ರಿ ಸರ್. ಸೊ ನನ್ನ ವೈಯಕ್ತಿಕವಾಗಿ ಮತ್ತು ನನ್ನ ಅಕಾಡೆಮಿಯ ಪರವಾಗಿ ಒನ್ಸ್ ಅಗೇನ್ ಥ್ಯಾಂಕ್ ಯು ಸರ್.
ಥ್ಯಾಂಕ್ ಯು, ಎಲ್ಲರಿಗೂ ನಮಸ್ಕಾರ.
ಸೊ ಹಾಗೂ ಈ ಒಂದು ಕಾರ್ಯಕ್ರಮಕ್ಕೆ ನೆರವಾಗಲ್ಲದಿದ್ದರೂ ಕೂಡ ನಮ್ಮ ಅಕಾಡೆಮಿಯ ಅಧ್ಯಕ್ಷರಾದಂಥ ಹಯ್ಯಪ್ಪನ್ ಸರ್ ಕೂಡ ಹಾಜರಾಗಿದ್ದು ಅವರಿಗೂ ಕೂಡ ಧನ್ಯವಾದಗಳನ್ನು ತಿಳಿಸುತ್ತಿದ್ದೇನೆ. ಹಾಗೂ ಈ ಒಂದು ಕಾರ್ಯಕ್ರಮವನ್ನು ಆಯೋಜಿಸಿ ನಮಗೆ ದಿನನಿತ್ಯವೂ ಸಲಹೆ ಸೂಚನೆಗಳನ್ನು ನೀಡುತ್ತಾ ಬಂದಿರುವ ನಮ್ಮ ಅಕಾಡೆಮಿಯ ಮುಖ್ಯ ಕಾರ್ಯನಿರ್ವಹಣಾಧಿಕಾರಿಗಳಾದಂತಹ ಡಾಕ್ಟರ್ ರಮೇಶ್ ಸರ್ಗೂ ಕೂಡ ಧನ್ಯವಾದಗಳು ಸರ್. ಹಾಗೂ ಈ ಒಂದು ಕಾರ್ಯಕ್ರಮದಲ್ಲಿ ಹಾಜರಾಗಿದ್ದ ನನ್ನ ಎಲ್ಲ ವಿದ್ಯಾರ್ಥಿ ಮಿತ್ರರು, ಟೀಚರ್ಸ್ ಅಂಡ್ ಸಹೋದ್ಯೋಗಿಗಳು ಹಾಗೂ ವೆಬೆಕ್ಸ್ ವೃಂದದವರು ಕೂಡ ಧನ್ಯವಾದಗಳನ್ನು ತಿಳಿಸುತ್ತಾ ಈ ಒಂದು ಉಪನ್ಯಾಸ ಕಾರ್ಯಕ್ರಮವನ್ನು ಮುಗಿಸುತ್ತಿದ್ದೇವೆ. ಸೊ ಈಗ ಮತ್ತೊಂದು ಉಪನ್ಯಾಸ ಕಾರ್ಯಕ್ರಮದಲ್ಲಿ ಡಾಕ್ಟರ್ ನವೀನ್ ಕುಮಾರ್ ಸರ್ ಅವರು ಸಾಲಿಡ್ ಸ್ಟೇಟ್ ಎಂಬ ವಿಷಯದ ಮೇಲೆ ನಮ್ಮೆಲ್ಲರಿಗೂ ಉಪನ್ಯಾಸ ನೀಡಲಿದ್ದು ತಾವು ಅದೇ ರೀತಿ ಯಾವ ರೀತಿ ಹಾಜರಾಗಿದ್ರೆ ಅದೇ ರೀತಿ ಹಾಜರಾಗಬೇಕೆಂದು ಮತ್ತೊಮ್ಮೆ ತಿಳಿಸುತ್ತಿದ್ದೇವೆ. ಒನ್ಸ್ ಅಗೇನ್ ಥ್ಯಾಂಕ್ ಯು ಸರ್.
ಥ್ಯಾಂಕ್ ಯು ಸರ್, ಥ್ಯಾಂಕ್ ಯು, ನಮಸ್ತೆ.
ನನಗೆ ಅದನ್ನು ನೋಟ್ಸ್ ಕಳಿಸ್ಕೊಡಿ ಸರ್ ಪ್ಲೀಸ್.
ಸರಿ ಸರಿ, ಥ್ಯಾಂಕ್ ಯು.
ಓಕೆ, ಥ್ಯಾಂಕ್ ಯು ಸರ್, ಥ್ಯಾಂಕ್ ಯು. ಸರ್ ನವೀನ್ ಸರ್.
ಸರ್ ಗುಡ್ ಈವ್ನಿಂಗ್ ಸರ್.
ಗುಡ್ ಈವ್ನಿಂಗ್ ಸರ್. ಆಯ್ತಾ ಸರ್ ಕಾಫಿ ಎಲ್ಲ?
ಆಯ್ತು ಸರ್, ತಮ್ದು ಆಯ್ತಾ ಸರ್?
ಎಸ್ ಸರ್ ಆಗಿದೆ.
ಸರ್
ಸೊ ಈಗ ಸ್ಟೂಡೆಂಟ್ಸ್ ಆಲ್ರೆಡಿ ಹಾಜರಾಗಿದ್ದಾರೆ ಸರ್ ಈಗ ಆಲ್ರೆಡಿ.
ಓಕೆ ಸರ್, ಫೈನ್.
ಸೊ ವಿಲ್ ಗಿವ್ ಒನ್ ಸ್ಮಾಲ್ ಇಂಟ್ರೊಡಕ್ಷನ್ ಅಬೌಟ್ ಯು ಸರ್.
ದಟ್ ಈಸ್ ನಾಟ್ ರಿಕ್ವೈರ್ಡ್. ಐ ವಿಲ್ ಇಂಟ್ರೊಡ್ಯೂಸ್ ಮೈ ಸೆಲ್ಫ್ ಅಂಡ್ ಸ್ಟಾರ್ಟ್ ಸರ್, ನಾಟ್ ಎ ಪ್ರಾಬ್ಲಮ್. ಅದೇನಿಲ್ಲ ಫಾರ್ಮಾಲಿಟೀಸ್.
ಸೊ ಇವತ್ತಿನ ಈ ಒಂದು ಉಪನ್ಯಾಸ ಕಾರ್ಯಕ್ರಮ ಮಾಲೆಯಲ್ಲಿ ಮತ್ತೊಬ್ಬ ತಜ್ಞರಾದಂತ ಡಾಕ್ಟರ್ ನವೀನ್ ಕುಮಾರ್ ಸರ್ ಅವರು ಸಾಲಿಡ್ ಸ್ಟೇಟ್ ಎಂಬ ವಿಷಯದ ಮೇಲೆ ತಮ್ಮೆಲ್ಲರಿಗೂ ಉಪನ್ಯಾಸ ನೀಡಲಿದ್ದು, ಸೊ ಅವರನ್ನು ಈ ಒಂದು ಕಾರ್ಯಕ್ರಮಕ್ಕೆ ಬರಮಾಡಿಕೊಳ್ಳುತ್ತಿದ್ದು ವೆಲ್ಕಮ್ ಟು ಯು ಸರ್.
ಥ್ಯಾಂಕ್ ಯು ಸರ್, ಥ್ಯಾಂಕ್ ಯು ವೆರಿ ಮಚ್.
ಈಗಾಗಲೇ ನಮ್ಮ ನವೀನ್ ಕುಮಾರ್ ಸರ್ ಅವರು ಒಂದು ಉಪನ್ಯಾಸ ಕಾರ್ಯಕ್ರಮವನ್ನು ನಡೆಸಿಕೊಟ್ಟಿರುವುದರಿಂದ ಈಗ ಕಾಲಾವಕಾಶ ಕಡಿಮೆ ಇರುವುದರ ಕಾರಣ ಹಾಗೂ ಅವರ ಬಗ್ಗೆ ಆಲ್ರೆಡಿ ನಾವು ಒಂದು ಕಿರು ಪರಿಚಯ ಮಾಡಿಕೊಟ್ಟಿರೋ ಕಾರಣ ಸೊ ಈಗ ಸರ್ ಅವರನ್ನು ನೇರವಾಗಿ ಈ ಒಂದು ಕಾರ್ಯಕ್ರಮಕ್ಕೆ ಬರಮಾಡಿಕೊಂಡು ಓವರ್ ಟು ಯು ಸರ್.
ಥ್ಯಾಂಕ್ ಯು ಸರ್, ಥ್ಯಾಂಕ್ ಯು ವೆರಿ ಮಚ್ ಸರ್. ಥ್ಯಾಂಕ್ ಯು ಫಾರ್ ದ ಆಪರ್ಚುನಿಟಿ ಅಂಡ್ ಇಂಟ್ರೊಡಕ್ಷನ್. ಐ ವಿಲ್ ಸ್ಟಾರ್ಟ್.
ಪಿಪಿಟಿ ಶೇರ್ ಮಾಡ್ತೀರಾ ಸರ್ ಇವಾಗ?
ಅದೇ ನೋಡ್ತಾ ಇದ್ದೀನಿ ಸರ್, ಶೇರ್ ಆಗ್ತಾ ಇಲ್ಲ, ಅದಕ್ಕೆ
ಕೊಟ್ಟಿದ್ದೀನಿ ನಿಮಗೆ ಶೇರ್ ಆಪ್ಷನ್ ಕೊಟ್ಟಿದ್ದೀನಿ
ಸರ್. ಅಪ್ಲಿಕೇಶನ್ಸ್ ಶೇರ್ ಆಯ್ತಲ್ಲ ಸರ್?
ಸರ್
ಶೇರ್ ಆಗಿದೆಯಲ್ಲ ಸರ್? ಎಸ್ ಸರ್.
ಈಗ ವಿಸಿಬಲ್ ಸರ್, ಈಗ ವಿಸಿಬಲ್. ಅದು ಫುಲ್ ಸ್ಕ್ರೀನ್ ಮಾಡ್ಕೊಳ್ಳಿ ಸರ್. ಎಸ್ ಸರ್.
ಥ್ಯಾಂಕ್ ಯು ಸರ್.
ಓಕೆ ಸರ್.
ಎಲ್ಲರಿಗೂ ನಮಸ್ಕಾರ. ಗುಡ್ ಈವ್ನಿಂಗ್ ಆಲ್ ದ ಸ್ಟೂಡೆಂಟ್ಸ್, ಪಾರ್ಟಿಸಿಪೆಂಟ್ಸ್, officials of KSTA. I am Dr. D. Naveen Kumar, Professor and Head for PG Chemistry, Surana College. It's an autonomous institution affiliated to Bangalore University. Today we are discussing about a solid state, right? As we know, mainly there are three states of matters: solid, liquid, and then gas, right? The characteristics or property or applications or anything else we are going to decide on the basis of their physical and chemical property of the substance, right? Whether it is solid or it is liquid or it is gas, right? The property of or characteristics of that particular matter is depending upon, as we know, each and every substance is made up of molecules. Each and every molecules is made up of atoms. Each and every atoms is made up of protons, neutrons, and electrons. The behavior of atoms, particles, and molecules decides the state of that particular matter. Today, we are going to start with solid state. Apart from liquid and gaseous status, solid state is also a state of matter, right? Solids have very strong intramolecular interaction. That means the space between the two consecutive molecule inside the substance. As I told, a solid is a molecular arrangement inside the, whether it is atoms or ions or particles inside the state, right? This is a strong intramolecular interaction, and there are very few vacant space. They have a particular space, particular orientation, direction, particular position. There are no random movements of these molecules or particles or particles or atoms, ions present inside the solids substance. Okay, right? That solid substance, the molecules movements are very less, only the vibration movement will be observed. They are arranged impactly, and then they have no vacant place to move between the atoms, ions, and molecules. The intramolecular distance means the distance, the space between any two consecutive molecules of a substance. Okay, that intramolecular interaction is strong, and also they have no vacant place between the atoms, ions, and molecules inside the solid. As a result, they have a particular shape and then volume and mass. They have a definite shape, definite volume, and definite mass when compared to the gases and liquid. As we know, the liquid, the molecular movements are random. Okay, because of that random movement, we are going to measure the viscosity of the liquid. The viscosity gives the liquid characters, right? The friction between the molecular layers. In the solid, they have no friction because they have no movement of the molecules or particles, ions present inside that. Some characteristics property, the few characteristics property of the solid states are, as I told, they have a definite mass, volume, and shape. Why? Because intramolecular interaction, and they have no space between the molecules, atoms, and ions. Okay, they are strongly bounded, right? Then intramolecular distance are short, and intermolecular force are strong. The force between the same, the space between any two consecutive molecules of a substance is called as intermolecular distance. The force between any two constitutive molecules of a substance is called intermolecular force. The intermolecular force between the molecules are very strong in a solid. Okay, they constitute particles like atoms, molecules, or ions. As I told, the substance is made up of molecules. Molecules is made up of atoms. Then atoms are protons, neutrons, or electrons. They have a fixed position. Okay, they cannot move. They're only the oscillated about their mean position. Only the vibrational movement can be observed in a solid state. Okay, they are incompressible and rigid because, as we know, the molecules are specific position and specific direction, and then they are strongly built with intramolecular this force, and there are no distance in molecule to molecule. That's what it's impossible to compress that solid. Okay, the liquid can compress because its movement is random, right? And then it's not, the liquid is not rigid, just smooth, and then slow movement, because it's that solid state is a rigid state. As I know, as we know, the solid having made up of molecules, the molecular force are very strong between intermolecular force are very strong. These are all the few important characteristics of solid state. Okay, right? Then solid state or solids are further classified. As we know, rubber is also a solid, sugar is also a solid, right? Salt is also a solid, and then some metals or glass are also a solid. Right. On the basis of that characteristics property, solid states are mainly classified into two types, that is amorphous solid and crystalline solid. Hello, sir, am I audible? Am I audible? Okay. The solids are of two types, amorphous and crystalline solid. Solid can be classified as crystalline and amorphous on the basis of the nature of order present in the arrangement of their constituent particles. As I told, the particles distance or the molecular distance inside the solid, the molecular force inside the solid, inside the substance decide the characteristics of that particular matter. Here we are talking about the solids. Okay, solids can classified on the basis of their arrangement of their constituent particles inside the solid substance. Amorphous solids behaves like a supercool liquids as their arrangements particles are short range. The distance between the molecules or particles inside the substance is short range, isotopic in nature. Isotropic, as we know, isotropic, the isotropic means, see, it gives a different, sorry, a substance have a physical property which has the same in all the direction. Any substance, the physical property is same in all the direction. That substance is called as that isotopic in nature. Clear? Anisotropic means it gives a different characteristics, a different physical property. I'm talking about physical property, the different physical property. When a light is passed through a substance, okay, in any direction you pass the light, sir, some substances are showing same physical property in all the direction. That type of substance is called as isotopic in nature. Some of the substances which shows a different characteristics in different physical property or different physical characteristics in different direction. That is anisotropic in nature. This amorphous solid is isotropic in nature. There is a sharp melting point. Example, as we know, glass, rubber, pinch, many plastics are amorphous solid. The crystalline solid, this play a very important role in solid states. Okay, the almost all the solids characteristics are were observed crystalline solid. The crystalline solid have a definite shape with the arrangements, with the arrangement of constituent particles of a long range order, anisotropic in nature, and sharp melting point. Yes, when we, if the molecules are in a definite position and the mass is known, obviously that's a sharp melting point. And anisotropic means it gives a different physical property in a different direction. That is also measures the characteristics of that particular solid. A distinction between crystalline and amorphous solid, as we know, they are called true solids because the molecular arrangements or intramolecular force are very high in the inside the substance, solid substance, and then intramolecular distance is also very short. They have a rigid in nature. It is not possible to compress that solids. That's what these are all the special characteristics of solid. That's what this is. This crystalline solid we call as a true solid. Here in amorphous solid, okay, there is a pseudo solid. Why? Because the intermolecular distance between the molecules, okay, right, is very short, and the intermolecular force between the molecules are less. That means some vibration or some movement of molecules or ions, atoms will observe in the amorphous solid. Okay, the in crystalline solid, the regular and definite arrangement of particles inside the solid. Here, no regular arrangements of the particles. They have a long order arrangement of constituents. They're short order arrangement of constituents. Short order, that's what they have no sharp endpoint for uh, this amorphous solid. Crystalline solid having the sharp melting point. Amorphous solid can be easily melted over a range of temperature. As you know, the plastic and candles. Candles, it's a very less temperature get melted, right? That is also example for solid. Plastic is also an example for solid. Sometimes when we increase the more than normal temperature, it will get melted. Okay, or else it responds for the temperature. But when we are talking about crystalline solids, where it's not response for a particular temperature, they have a sharp melting point. At that particular point, that crystal get melted, right? This is the crystalline solid characteristic. They have a clean and smooth edges when cut. When we cut the solid materials, okay, solid, for example, when you take wood as an example, but you will get a correct, definite shape and size of that particular solid. Two pieces when you get, okay, right? When we cut a amorphous solid, they have irregular and rough edges. We are not able to ನೀವು ಯೂಸ್ ಮಾಡ್ತಿರಲ್ಲ ರಬ್ಬರ್ ಓಲ್ಡನ್ ಡೇಸ್ ಯೂಸ್ ಟು ಯೂಸ್ ಪೆನ್ಸಿಲ್ ಯೂಸ್ ಮಾಡ್ತಾ ಇದ್ರು. ಕರೆಕ್ಟ್, ಪೆನ್ಸಿಲ್ ಯೂಸ್ ಮಾಡುವಾಗ ಪೆನ್ಸಿಲ್ ಬರ್ತನ ಅದನ್ನ ನಾವು ರಬ್ ಮಾಡ್ತಾ ಇದ್ವಿ. ರಬ್ ಮಾಡ್ತಾ ಇರಬೇಕು ರಬ್ಬರ್ನ ಯೂಸ್ ಟು ಕಟ್. ನಿಮ್ಮ ತಮ್ಮನೋ ಅಥವಾ ನಿಮ್ಮ ಅಣ್ಣನೋ ಯಾರಾದ್ರೂ ಕೇಳಿದ್ರೆ ಕಟ್ ಮಾಡಿ ಎರಡು ಭಾಗ ಮಾಡಿ ಎರಡನ್ನ ಯೂಸ್ ಮಾಡ್ತಾ ಇದ್ರು ಕಟ್ ಮಾಡಿದಾಗ. ಸಿ when we cut the rubbers, we can't get a smooth edges or clear edge while we are cutting. Same we are using the pencil use ಮಾಡ್ತಾ ಇದ್ವಿ. ಯಾವ್ದಾದ್ರು ಇನ್ಸ್ಟ್ರೂಮೆಂಟ್ ಯೂಸ್ ಮಾಡಿ ಪೆನ್ಸಿಲ್ನ ಕಟ್ ಮಾಡಿದ್ರೆ then we will get a correct smooth edge, right? That is the characteristics of crystalline solid. Because the arrangement of the molecules are proper, arrangement of constituents inside the solid is proper. Here in amorphous, irregular arrangement of the constituents will be ends will be observed. Okay, they have a definite heat of fusion that is related to the same melting point. Okay, the crystalline, as I told, the crystalline solid is a very important role, play a very important role in that solid state. The crystalline solids are classified into, as we know, solids are classified into amorphous solid and crystalline solid, depending upon the molecular arrangements. Clear, depending upon the intramolecular force or intramolecular distance. Okay, in future I'll explain you the covalent bond and metallic bond, right? And then polar and non-polar materials, that is different. Here in basically the amorphous solid and crystalline solid is based on the arrangement of molecules or intramolecular force or intramolecular distance between the molecules inside the solid state. The crystalline solids are once again classified into covalent or network solids, okay, and then metallic solids, ionic solid, molecular solids, right? Once again, that molecular solids are further clarified into polar solids and non-polar solids, hydrogen bonded solids. Okay, right? That is also different. Covalent or network solids, metallic solids, ionic solids, and molecular solids are classified on the basis of the molecular arrangement inside the solid, or else the molecular movement, vibration inside the solid, and the pair, electrons pair, or the metal ions present in that distribution of metal ions. That is, see, the covalent or network solids are also further classified two-dimensional solid, three-dimensional solid. Let us discuss one by one. Say in molecular solids, non-polar molecular solids. Those solids are formed from molecules or atoms that share a non-polar covalent bond. The atom or molecule are held by weak dispersion force or by Langdon force. That means that the atoms or molecules are held by weak force in between the nearby or constituent molecule. We know what do you mean by polar and non-polar. When the things is different in each end, we call it as the polar. when the things are same in each end, that is called as non-polar. Each end means the substance, the molecule, some molecules having both positive and negative end. Okay, hydrophobic and hydrophilic. Hydrophobic means it's water hydrogen ion acceptable and hydrogen ion rejectable. Both the ends having different things. One end having positive ions, another end having negative ions. That type of substance is called as polar molecule or polar substance, right? Non-polar, the same end in both the sides, right? The physical nature of non-polar solids are soft. Okay, they do not conduct electricity, so they are insulators. They are neutral, right? They have a very low melting point. Example: H2Cl2 I2, non-polar molecules. Non-polar molecules that have no two different things or different ends, right? When you take H2O, H2O is a polar. It contains H plus one end and OH minus another. Both the positive and negative ends will be observed in this polar molecular solid. Here, non-polar molecular solids, both the ends are same. Okay, and then polar molecular solids. Those solids are held together by polar covalent bonds. Covalent bonds is a electron, the sharing of electrons pair between the atoms. That is called as covalent bond. Sharing of electrons pairs between neighbor atom and the same atom, right? This type of polar molecular solids are held together by polar covalent bonds. Okay, sharing of electrons in between the atoms with polar molecules, and the atom molecules are bonded by relatively strong dipole-dipole interaction. The physical nature is soft, and most of these are gases or liquids at room temperature. They do not conduct electricity and they have a higher melting point than the non-polar molecular solid. Non-polar molecular when compared to non-polar molecular solid, just the melting point of the polar molecular solids is higher. Examples are HCl, SO2, NH3, right? Hydrogen bonded molecular solids. Okay, the solids contains polar covalent bond as same as the same polar molecular solid. Polar covalent bond means the sharing of electrons pair by nearer atom with hydrogen, fluorine, oxygen, and nitrogen. In this solid molecule are held together by a strong hydrogen bonding. See the difference between polar molecular solid and then this one hydrogen bonded molecular solids are the polar covalent bonds which sorry for the convenience. See here in hydrogen bonded molecular solid, okay, right? The polar molecular solid is strong polar covalent bond. Here the strong polar covalent bond held by hydrogen bonding, strong hydrogen bonding. There's this physical nature of such solids are hard. There's only when we're talking about polar molecular solid, it's a soft because there are no strong bonding between the polar coordinate bonds. Here, strong hydrogen bondings between the polar covalent bond. The physical nature is hard. They do not conduct electricity. The physical state of these solids are volatile, liquid, or soft solid under the room temperature. These are all the same thing. They have a low melting point. Examples are water. Then there's another type of solids or ionic solid. The names ionic solid constitutes particles or ions. The particles in the solid presents are ion. Those are formed by the arrangement of cations and anions by strong Coulombic force. As we know, we are all familiar about these ionic solids because sodium chloride, zinc sulfate, calcium chloride, these are all It consists of Na plus and Cl minus ion, both cation and anion, that together with a Coulombic force. Obviously, they are together with a strong force. These are hard and brittle in nature. Ionic solids act as the insulator in solid state, but are conductor in the molten and aqueous state. When we dissolve in water, it's conduct electricity. Okay, right? When it's in a solid state, it acts as an insulator because it's a neutral, Na plus and Cl minus. They have a high melting point. Okay. Metallic solid. Positive metal ions in a sea of delocalization electrons. Delocalization electrons. The electrons in an atom, ions or molecule that not connected to the single atom. See, the delocalized electrons, it's very simple. The electrons, delocalized electrons is an electron. It is not connected with a single atom inside the solids atoms. Okay, it's completely movable around inside that. These electrons are evenly spread out throughout the crystals. It spread it is throughout the crystals. Okay, due to the presence of free and mobile electrons, they are responsible for high electric and thermal conductivity. As we know, the conductivity value is directly depends on the mobility of the ions, right? The mobility of the ions is directly depends on the movement of that is called as movement of the free ions present in the solution, right? Then they are here, as I told, delocalized electrons are present. Because of that presence of free electrons, they are responsible for high electric and thermal conductivity. Conductivity depends on the mobility of the ions. Okay, they are conductors in both solid and molten state because it contains highly mobile electrons, or less mobile or highly mobile. The mobile electrons are available. That mobile electrons are responsible for conducting the electricity. Okay, it conducts both the solid and molten. The physical nature of those solids are hard, but they are and ductile, malleable and ductile. Even though it's hard, they have a high melting point than ionic solids. When compared to ionic solids, they are having a very high melting point. Example: iron, copper. Covalent or network solid. A wide range of crystalline solid, non-metal from covalent bond between adjacent atoms throughout the crystal and forming giant molecular large molecule. Okay, this crystalline solids are different types of solid. This non-metal from covalent bond. Covalent bond, the bond between the two adjacent atoms. The covalent sharing of free electrons. Once again, non-metal covalent bond, not free the electrons sharing. Then that crystals form a giant molecule or large molecule. It contains a large number of molecules. The solid are hard like diamond and soft like sea. When it's the as I told, the covalent bond between the sharing of electrons. Okay, here non-metal form of covalent. Then this is a very hard solid. Okay, the examples are diamond, graphite, carbon. They are insulated as in the case of diamond, but in the case of graphite, due to free electrons, they conduct electricity and acts as a conductor. Then this molecular arrangement in the crystalline solids, okay, explained on the basis of crystal lattice. Okay, crystal lattice. The crystal structure is made up of atoms. The complete crystals, as I told, the solid substance is made up of the molecules. The molecules are made up of atoms. Atoms are once again proton, neutron, electrons. The crystal structure is made up of atoms. A crystal lattice is made up of points. A crystal system is a set of axes. In other words, this is a crystal lattice used to explain the number of unit cells. Okay, present in the crystal lattice structure. The structure is ordered array of, it's a packets of atoms, ions or molecules inside the crystal solid. That crystal solids or solid behavior can be explained on the basis of atoms, ions or molecules present inside them. As we know, it's a particular arrangement. Okay, see, characteristics of crystal lattice. Each point in lattice is called as lattice point and lattice site. The point at which the lattice, each point in a crystal lattice represent one constituent particle, which may be an atom, a molecule, or a group of atoms, or an ion. Each point in a crystal lattice represents, we are going to represent the atom, molecules or ion in, as I told, the lattice, this crystal lattice is made up of points. The crystal structure is made up of atoms. This crystal lattice is nothing but, we have to, this crystal lattice explain the arrangements of atoms, ions and molecules in the lattice points are joined by straight lines to bring out the geometry of the lattice unit cell. This is the important thing in a lattice structure. The smallest repeating unit of the crystal lattice is the unit cell. Okay, in a lattice, in a crystal lattice structure, the unit, the smallest, that means a single atom or single mat in the unit in a lattice, crystal lattice is the unit cell. The building block, this is the building block. This unit cell is the complete building block of a crystal. As we know, the polymer, the monomer is a unit or building block of a polymer, right? A single thread, as we know, the one single thread in a silk material. Okay, one single thread we called as a monomer. The combination of monomers will get a polymer, right? Like that, this is a single unit, that is unit cell. That unit cell is the building block of a crystal lattice or a crystal. The types of unit cell, there are different types of unit cell inside the crystal lattice or crystal. Okay, primitive cubic unit cell, body centered cubic is unit cell, face centered cubic unit cell. Why we are going to explain all this: primitive cubic unit cell, body centered cubic unit cell and face centered cubic unit cell? We have to explain, right, the lattice, crystal lattice of the particular crystal solid or solid property of the, say, number of atoms in a unit cell. Yeah, that is in primitive cubic unit cell. How much number of atoms present in that? The primitive cubic unit cell has atoms only at its corner. There is a lattice structure. There are corners and right side, left side, and each atom at its corner is shared between 8 adjacent unit cell. 1, 2, 3, 4, 5, 6, 7, 8. Okay, right? Cell in the same layer, 4 unit cell of the upper or lower, 4 plus 4, 8. Only 1/8 of the an atom actually belongs to a particular unit cell. That means the permanent cubic unit cell consists of only 1/8 of an atom actually. When we are calculate number of unit cell present in a crystal lattice, there is body centered cubic unit cell. This body centered cubic unit cell has an atom at each of its corner and also one atom at its center. So here 1, 2, 3, 4, 5, 6, 7, 8, 1 at the center. Okay, right? A number of atoms in body centered cubic unit cell. This in body centered cubic cell we have 8 corners. 1, 2, 3, 4, 5, 6, 7, 8. 8 corners. Okay. 1/8 per corner atoms. Kerner atoms 1 by 8, 1, 2, 3, 4, 5, 6, 7, 8. Okay, right? Then 8 into 1 by 8, 1 atom. Body central cubic cell. Number of atoms present in body central cubic cell is 8. See here in this primitive cubic center, 1 by 8 of the atom actually belongs to a particular unit cell. As atoms only in its corner, only the corner atoms can be shown. Here we have body centric cubic unit cell, 1, 2, 3, 4, 5, 6, 7, 8 corners, and then corners atoms 1 by 8 per corner atoms, 8 into 1 atom. One body center atom is equals to 1 into 1 atom. Therefore, the total number of atoms present in per unit cell. So a single unit cell consists of 2 atoms. Right, we can measure at any crystal lattice point, we can measure the body center cubic unit cell, 2 atoms in a atoms present in a unit cell. Face centered cubic unit cell. This face centered cubic unit cell contains atoms at all the corners and the center of all the faces of the tube. The atom present at this face center is shared between 2 adjacent units. This is a little bit, see, in body center cubic cell 1, 2, 3, 4, 5, 6, 7, 8. Center, the cubic centers contain atom at the corner and the center, all the faces of the cube. The atom present at the face center is shared between 2 adjacent unit cells. 1, 2 adjacent unit cells, and only 1 by 2 of each atom belonging to an individual cell. This is 1, this is 1. 1 by 2, each atom belongs to individual cell. Number of atoms in BCC cell, as we know, 8 corners, 18 per corner atoms, 8 into 18, 1 atom. This is 1 by 8 per corner atom. It's not 18 per corner atom. 1 by 8 per corner atom, 8 into 1 by 8 is 1 atom. Okay, 6 face centered atoms. 1, 2, 3, 1, 2, 3. 6 face center atom. 12 atoms per unit cell. For two atoms per unit cell. Here 12 atoms per unit cell. Then the total 6 face center atoms, 3 atoms. Hence the total number of atoms in a unit cell is 4 atoms. In face center cubic unit cell, 4 atoms. In this body center cubic cell, 2 atoms. Here in the primitive cubic cell, this is 1 by nth of the atom actually belongs to a particular unit cell. This is 1 by 8th 1 by 8th of the actual belongings to the particular unit cell. Then this is crystal lattice. On the basis of this crystal lattice, okay, we can explain the ionic solids and constitutive particles. Okay, right? Have you understood this 3 solid state classification, and then amorphous and crystalline solid? As I told, the amorphous example, glass, rubber, that's the special. Then on the basis of crystal lattice, the color and then the characteristics of the solid states can be explained, right, sir?
Thank you, sir.
Hello,
Thank you, sir.
am I audible?
Yes, sir. Audible.
Yes, sir. Yes, sir.
So you completed, sir?
Yes, sir. Yes, sir.
Yes, sir. Dear students, please ask any questions and doubts on today's
Any
topic.
discussion? Any discussion?
ಸೊ ಚಾಟ್ ಬಾಕ್ಸ್ ಸರ್ ಚೆಕ್ ಮಾಡ್ತೀನಿ ಸರ್, ಏನಾದ್ರು ಕ್ವಶನ್ಸ್ ಹಾಕಿದ್ರ ಮಕ್ಕಳು ಅಂತ ಹೇಳಿ
ನೋಡಿ ಸರ್.
ಸೊ ಯಾವ್ದೇ ಕ್ವಶನ್ಸ್ ಇಲ್ಲ ಸರ್ ಚಾಟ್ ಬಾಕ್ಸ್ ಅಲ್ಲೂ ಕೂಡ.
ಓಕೆ.
ಸೊ ಅವ್ರು ಏನಾದ್ರು ಕಳ್ಸಿದ್ರೆ ಐ ಸೆಂಡ್ ಥ್ರೂ ಇಮೇಲ್ ಲೇಟರ್ ಆನ್, ಐ ಸೆಂಡ್ ಥ್ರೂ ಇಮೇಲ್ ಸರ್.
ಓಕೆ ಸರ್, ಓಕೆ ಸರ್.
ಸೊ ಈಗ ತಾವು ಇವತ್ತು ಕೊಟ್ಟಂತ ಉಪನ್ಯಾಸ ಕಾರ್ಯಕ್ರಮದ ವಿಷಯದ ಮೇಲೆ ಸರ್, ಅದು ನನಗೆ ಒಂದು 4 ರಿಂದ 5 ಪೇಜ್ ನೋಟ್ಸ್ ದಯವಿಟ್ಟು ನನಗೆ ಥ್ರೂ ಮೇಲ್ ಆರ್ ವಾಟ್ಸ್ಆಪ್.
I'll send this presentation and then notes for
ಇಲ್ಲ
this.
ವರ್ಡ್ ಡಾಕ್ಯುಮೆಂಟ್ ಅಲ್ಲಿ ಕೊಟ್ಬಿಡಿ ಸರ್ ನನಗೆ 2 ಕ್ಲಾಸ್.
Okay sir, okay.
ಪ್ಲೀಸ್ ಸರ್.
Course material. Thank you sir.
Thank you. Today delivered a very good informative talk on solid states. It is an immense pleasure to thank you, Dr. Naveen Kumar sir. ಸೊ ತಾವು ಈ ಇವತ್ತಿನ ಒಂದು ಉಪನ್ಯಾಸ ಕಾರ್ಯಕ್ರಮದಲ್ಲಿ ಸಾಲಿಡ್ ಸ್ಟೇಟ್ ಬಗ್ಗೆ ಹಲವಾರು ಉದಾಹರಣೆಗಳ ಮೂಲಕ ಮಕ್ಕಳಿಗೆ ಭಾರಿ ಹಲವಾರು ಮಾಹಿತಿಗಳನ್ನ ತಿಳಿಸ್ಕೊಟ್ಟಿದ್ದೀರಾ. ಸೊ ನನ್ನ ವೈಯಕ್ತಿಕವಾಗಿ ಹಾಗೂ ನಮ್ಮ ಅಕಾಡೆಮಿಯ ಪರವಾಗಿ ಧನ್ಯವಾದಗಳು ಸರ್.
Thank you sir, ತಮಗೂ ಧನ್ಯವಾದಗಳು.
Thank you.
This thing invitation and then opportunity to explain. Okay, thank you very much for all the KSTA officials and all the best. Thank you.
ಹಾಗೂ ಈ ಒಂದು ಕಾರ್ಯಕ್ರಮಕ್ಕೆ ನಮ್ಮ ಅಕಾಡೆಮಿಯ ಅಧ್ಯಕ್ಷರಾದಂತ ಪ್ರೊಫೆಸರ್ ಅಯ್ಯಪ್ಪನ್ ಸರ್ ಕೂಡ ಹಾಜರಾಗಿದ್ದು, ಸೊ ಅವರಿಗೂ ಕೂಡ ನನ್ನ ಧನ್ಯವಾದಗಳು ಸರ್. ಹಾಗೂ ಈ ಒಂದು ವಿಜ್ಞಾನ ಪ್ರತಿಭಾ ಶೋಧನೆ ಯೋಜನೆಯನ್ನು ಆಯೋಜನೆಗೊಳಿಸಿ ನಮಗೆ ದಿನನಿತ್ಯವೂ ಸಲಹೆ ಸೂಚನೆಗಳನ್ನು ನೀಡುತ್ತಾ ಬಂದಿರುವ ನಮ್ಮ ಅಕಾಡೆಮಿಯ ಮುಖ್ಯ ಕಾರ್ಯನಿರ್ವಹಣಾಧಿಕಾರಿಗಳಾದಂತಹ ಡಾಕ್ಟರ್ ರಮೇಶ್ ಸರ್ಗೂ ಕೂಡ ಧನ್ಯವಾದಗಳು ಸರ್. ಇಂದು ಹಾಜರಾಗಿದ್ದ ಎಲ್ಲ ವಿದ್ಯಾರ್ಥಿ ಮಿತ್ರರು, ಶಿಕ್ಷಕರು, ಸಹೋದ್ಯೋಗಿಗಳು ಹಾಗೂ ವಿವೇಕ್ಸ್ ವೃಂದದವರಿಗೂ ಕೂಡ ಧನ್ಯವಾದಗಳನ್ನು ತಿಳಿಸುತ್ತಾ ಈ ಒಂದು ಉಪನ್ಯಾಸ ಕಾರ್ಯಕ್ರಮವನ್ನು ಮುಗಿಸುವತ್ತ ಹಾಗೂ ಮತ್ತೊಮ್ಮೆ ಎಲ್ಲರಿಗೂ ಧನ್ಯವಾದಗಳು. ಒನ್ಸ್ ಅಗೇನ್ ಥ್ಯಾಂಕ್ ಯು ಸರ್.
Thank you very much sir. Thank you.
Please send me sir, ನಾನು ಕಳಿಸ್ಕೊಡಿ ಸರ್.
Yes sir.
Okay. Thank you sir. Thank you very much. Bye.